Hello friends, in this video we want to take a look at packet tracer 2213. Yes, area OSPF. This is point-to-point area OSPF version 2 configuration. You can see this topology here. We have 1, 2, 3, 4, 5, 6 networks here between two routers, and we want to establish routing protocol between them, because we have router and the router works in layer 3, and to communicate together we need to have a routing protocol, as you know. And in this example and in this activity we should configure OSPF. Yes, open shortest path first, and as you know, OSPF is a dynamic routing protocol which work on the link state algorithm, because we have link state and distance vector for routing protocols, and link state means each router advertise it's a connected links info to all the networks devices and all the routers in the network. But unlike this distance vector, that each router was just aware of its neighbor, not all the routers in the network. Okay, we should go to objectives and check objectives are configure router ID and configure networks for OSPF routing and configure passive interface and verify OSPF configuration. In part 1, we should start the OSPF routing process on all 3 routers. Use process ID 10. As you know, every router requires router ID. Why? This is router ID. This is router ID 111. And before that, we should talk about process ID. Process ID is a number. For example, if two router or three router like R123 wants to make and establish neighborship, they should have same process ID, like for example 10, and in this situation can communicate together and establish neighborship. And after that, also use the router ID command to set the OSPF IDs of the 3 routes as follows. For example, router 1, router 2, router 3, 111, 222, and 3333. Every router requires a router ID. Why? Because they want to participate in OSPF domain, and it's like a requirement. And router ID is a unique number, maybe can define by administrator, like this example that we want to do that and configure it. And maybe automatically, if we don't define it, it will be automatically from IP address, highest IP address, and also other section and other thing. And in this situation, all the routers should participate in designated router election. Designated router election is like a leader router, that all of the routers should send information and should send all of the networks and all of the information to DR or designated route. And designated route is responsible for syncing all the other routes like a leader. Okay, we should start from router 1 here. And yes, we can write here enable and conf t. Yes, conf t. After that, we should create router OSPF10. And on the router OSPF we have created, and on the router OSPF we should write here router ID 1111. And also same process for here for router configure terminal and router OSPF. This is routing protocol and number, same like R1 and R3 because we want to establish neighborship. And also router ID should be 2222. The highest router ID should be elected as DR, and in this situation router 3 will be elected, and we manipulate election with this process, okay? Because it's very important for us in large networks. Router OSPF 10 and router ID 3333, okay? And other thing we should go and following here, configure network for OSPF routing. How many statements are required to configure OSPF to route all the networks attached to router 1? Router 1 has connected to 3, one router and another router and another LAN here. We want to have 3 here because only this path that connected direct to router 1 is important for us, and we should advertise this 3 here and send to DR, and DR send to all of the router in this topology and in this network. And the LAN attached to router 1 has a /24 mask. What is the equivalent of this mask in dot decimal representation? Yes, /24 is 255.255.255.0. It's better right here maybe. Yes. Oh, wow. Okay. Doesn't matter. Okay. Okay, 255.255.255.0. And what is the dot subtract the dot decimal subnet mask from 255.255.255.255? What is the result? Result should be, as you know, this is 0, 0, 0, and 255. Yes, it's subnet mask, and excuse me, it's a wildcard mask. Okay. And what is dot decimal equivalent of the /30 subnet mask? This is 255.255.255.252. And subtract the dot decimal representation of the /30 mask from 255.255.255. What is the result? The result should be 0033, and maybe we should write here all of the information. The first one is /24. Subnet mask is here, and wildcard mask is 0000255. And what about, for example, /30? 255, 255, 255, and 252. And wildcard mask should be, you should write here, for to calculate wildcard mask, you should write here minus 255, 255, 255, 252. It should be 0003. Okay, and A configure routing process on R1 with the network statement that and wildcard masks that are required to activate OSPF routing for all the attached networks. Okay, we should activate network. If you write activate network command here, network command help us and determines which interface participate in the routing process for an OSPF area. Okay, for example here, what is the network address that connected to R1? For example, this one, 10, 1, 1, and 4. And what is the wildcard mask? You can see here the command by default, wildcard mask. This is not subnet mask, wildcard mask. And only we have 3 here. And area ID should be 0 for all of the networks here. Okay? Area between 1 to this number and area 0. All of the router located in one area, because we have multi-area and single area, and in is single area, and we have only area 0. And other network that we have here, we have other also 10.1.1.0, and also this is /30, and same. And also we have 192, 168, 10, 0, and wildcard mask is 0, and wildcard mask is 255, and area is 0. Yes. And we should also go to router 2 and write here network. Which network connected to router 2? 10.1.1.8 connected to between router 3 and router 2, I mean. And wildcard mask is same, and area is 0. And other thing, we have also 110, and we have also here 100. This is LAN 192. What happened here? What happened? Because I have received information from any log and interrupted my command. And also should be 20 and 0, and yes, it should be 255, and area also 0. Yes, and same process for 10, 114, 0003, and area 0 for router 3, and also for other network here, 8. Oh. 8 and also yes, and 101 and 30 and 0, and subnet mask is 255 area 0. You can also see all of the information that you have right in here. Do show command, do show run, and you can see you have written these 3 networks here. And is it right or not right? Yeah. Okay, you should edit. Okay, and we have done it, all of them, for router 1, router 2, and router 3. We have configured network. And yes, configure networks for OSPF2 routing using interface IP address and QAD 0 mask, that we have done it. And step 3, configure OSPF routing on router interface. On router 3 also, we should configure interface with OSPF, that we have configured. And on router R3, configure the required interface with OSPF. Which interface on router 3 should be configured with OSPF? It should be this interface, S011, and this interface, yes, and G000. And also you can see here, G000, S011, 0, and S011. Yes, yes, I have described that. Why? Because it's directly connected to router 1 and router 2, and also LAN here. And yes, configure each interface using the command syntax shown below, that we have also done it. IPOSPF, for example, 10 and something like that. But in this situation, also you have also exit. You have also this option. You have also this option for configuring OSPF routing. Why or how? You can go to, for example, interface G00, 0, and right here IP OSPF 10 area. Which area? 0. And right here also interface serial 0, 1, 0. And right again IP OSPF 10 area 0. And same process for 0, 1, 1. And also is the another option that you can also create OSPF here. Yes, OSPF 10. And yes, it's here, and its instruction is here. And in part 3, configure passive interface. What is passive interface? Passive interface, we have some devices that cannot participate in advertising networks, in election, and something like that. For example, computer and devices like a PC and laptop, printer cannot participate in this process, or also this switch here, because only router gets information from other routers and sent to other routers and sent to DR or designated router to be updated and get a status from other devices and other layer 3 devices. And in this situation, you need to send all of the information every minute to PC. In this situation, you say, this G000 should be passive interface and it doesn't need to send information to PC in this interface, and also for R2 in this interface, and also for R1 in this interface. And we should deactivate it and disable it. You should go to router 1 here, and under router OSPF10, we are under router here, OSPF10, and we can write here passive interface. Which interface is passive? You can see which interface. Maybe this is gigabit or serial or something like that, but it's for all of the router is G000. You can see here. Yes, G000. Yes, and we can also write it for passive interface G00, and also same process for router OSPF exit router OSPF 10 that we have configured before, and right here passive interface G000. Okay, PC doesn't need any status and any advertisement from other devices because cannot communicate with other routers directly, and is also passive interface. And verify OSPF configuration. Use show command to verify the network and passive interface configuration of the OSPF process on each devices. You can write here, for example, switch 3, and in privileged exec mode, you can write here show run. You can see all of the information and configuration that you have done here, and passive interface. And also you can write here show IP route, and you can see which route, this is routing table, which route that you have configured. O, it means OSPF, and you should check you have configured this network here, and this is administrative distance for OSPF. This is by default 110. But what is 128? This is cost of this pass, and we should talk about this assignment and this feature in other assignment and other activity, and you can see how many minutes ago that we have configured and which the interface that we have configured and all of the information here. Also, you can see other thing here about this network address, and you can see we have only connected to 192.168.0, but you have also gotten this also LAN and this LAN information, because in link state routing protocol and dynamic routing protocol, and in link states routers like OSPF can get all of the information from all of the routers in the networks as I described for you. And in this situation, you can also see this LAN and this LAN here, and also other thing. And you can also check show IP protocol. Show IP protocol. You can see your router ID and which router ID that we have a router process ID that we have done, and some information about which networks connected to this device, and we have configured, and also passive interface that we have done it, and what is the neighbor of 333 is 222 and 111, and also 33, and also the administrative distance here, and last update, and something like that. Other information here, and also you can write here show OSPF, show IP OSPF, show IP OSPF, and for example, you can write here neighbor, and you can see which neighbor that we have. We have neighbor 1 and neighbor 2. Yes, this is router ID, and state is full, and the time, and also address for them, and interface that connected to router 11 and router 2222. And also you can see other information here, database, and yeah, a lot of information. Also you can see here interface, for example, gigabit 0, 0, 0, and you can collect and gather a lot of information about adjacency and router ID, and a lot of information is here. And also we have 4 packets here. You can see hello packet, did packet, wait, and something like that, and whatever. Okay, thank you for watching, and please subscribe me and support me, and please ask me any question if you confront any problem, issue, and something like that, whatever. Have a nice day.